Hello and welcome to York Observatory YouTube TeleTube. This is the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'm Elaina Hyde, and we're here today with a very, very special broadcast. I am joined with all kinds of fun folks, and we're going to be talking about the 2021 partial eclipse that is happening or has happened early this morning here in Toronto, Ontario, Canada. Of course, this eclipse has all kinds of great fun facts about it. It is an annular eclipse, but we only saw it as a partial. Why is that? Well, I am joined this afternoon by Professor Delaney, Quinton, Noah, and Kat, and we have a huge amount of pictures, videos, and all kinds of great stuff for you today, captured this morning at the wee early hours. So we'll go ahead and without further ado, get started with the broadcast. So welcome everyone, and I believe we have Professor Delaney here hiding out as well. So Professor Delaney, come on in and say hi.
Hi there. Hi, what a great day. Beautiful temperatures, lots of sun. What more could you ask for to watch a solar eclipse, eh?
Well, and we have a backup episode that happened just last night on TeleTube all about eclipses. But just in case anybody missed that episode, I believe, Quentin, you were going to have a look and tell us a little bit more just about, as a reminder, what are solar eclipses?
Yeah, thank you for having me. So essentially what a solar eclipse is it's a situation where the sun, the moon, and the earth are all lined up in such a way so that the sun is in front and the moon blocks the sun's light from a part of the earth. So the earth essentially falls, or a part of the earth falls into the moon's shadow. For solar eclipses, the sun appears to be behind the moon, and the moon can either block it partially or entirely. And this effect is thanks to the fact that the sun's diameter is about 400 times larger than the diameter of the moon, but it also happens to be about 400 times farther away, which means that under the right conditions, you can actually have complete obstruction of the sun. And that's what we see in a total eclipse, like the ones being shown on this slide right now. And when that happens, you actually get to see a part of the sun that is normally completely invisible to us, called the corona, which is this lovely white halo around the sun. But of course, that isn't what happened this morning. What happened this morning was, depending on your geographical location, either a partial eclipse or a total eclipse. So in Toronto and in all of these regions shown on this globe here that are within this like shaded sort of oval almost, not this orange band. We'll get to that in a second. You have an effect called a partial eclipse. So in these portions of the earth, the sun and moon don't line up perfectly. And rather than the moon completely overlapping with the center of the sun, you instead have it appear to sort of take a bite out of the side of the sun. This is a partial solar eclipse. These are of course fascinating occurrences. This is exactly what we were able to fortunately see in Toronto this morning, and we have several images of that. But of course, we also have another type of eclipse that can occur, which is called an annular solar eclipse. And an annular solar eclipse is a situation in which the moon is near its apogee, which means that it is relatively far away from the Earth in its orbit. And at a time like this, even if the sun and the moon align perfectly in the sky, because the moon occupies a smaller angular diameter than the sun does, because it appears to be smaller than the sun is, it won't be able to cover the sun entirely. And rather than blocking out the brightest parts of the sun and allowing us to see the corona, instead we get this really interesting ring of fire effect. So for anybody who was on the orange band on the globe that we portrayed earlier, so this would have been regions of northern Ontario, parts of Quebec, especially the Ongava Peninsula, parts of Baffin Island, including Iqaluit, and parts of the far east of Siberia. You would have, at some points in the previous few hours, have been able to see this fascinating annular eclipse effect. Now, all the images that we are going to be showing you tonight were taken in the Toronto area and are going to show a partial eclipse. And these were taken by our very own observatory members. So I am very, very impressed by the number of images we were able to take. I'm extremely happy with how they all turned out, and I hope that you're all going to enjoy them too. Elaina, if you'd like to take over the mic now and introduce these to the audience, you can.
Wonderful. And yes, I'll go ahead and thanks for that great recap, Quinton. It's obviously very exciting because we did have on Earth a annular solar eclipse, but from Toronto, we saw it as a partial solar eclipse. So what did we see? Well, we saw all kinds of things because unlike other types of astronomical events, this particular eclipse, we couldn't just point our telescope up at it and then send you the live images over YouTube like we usually do. No, this was happening as the sun was rising. So this was why we all got up, or well, some of us, a large number of us got up at 4:30 a.m. this morning, went down and found a place where we could look east and see the horizon because our telescope cannot point low enough in the sky to actually catch the sun as it's coming up. And of course, even if we could, we'd still need a clear view to the sunrise in that east direction. So, as a great solution, our observatory crew got up really early this morning and we scattered to all directions of the general Toronto, Ontario-ish area. So we had, and this is just to get us started off, we had all kinds of people in all kinds of places taking pictures of this eclipse. So I'll go ahead and start off with Jesse and Alex, observatory members. So Jesse Rogerson is a professor at York, and Alex is his wife, honorary observatory member. They went out with this small telescope here, and I believe, Paul, you want to chime in a little bit and to give some background on Jesse and this telescope since you know them so well?
Absolutely. I've known the C8, the Celestron 8, actually longer than I've known Jesse. The Celestron 8 was purchased by the observatory back in the 1970s. So this telescope is somewhere in the vicinity of 45 years old. It is one of those classic telescopes. It is the Celestron 8, the characteristic orange. It's 8 inches in diameter, which is 20 centimeters in diameter. By comparison with modern telescopes, of course, it doesn't have all of the bells and whistles, but it is a really sweet telescope. That is for sure. And you can see it here on location somewhere on the south side of Bradford, the north side of Newmarket. And Jesse and Alex were prepping it bright and early this morning for a nice observation of the solar eclipse. But yeah, it's a really sweet telescope. They don't make them like that anymore. And here we are 45 years later. Jesse, as you indicated, Elaina is one of our newest faculty members here at York, but he has been long associated with the observatory, is enjoying the views in the morning, and he mastered the process of actually taking a photograph with his cell phone through the eyepiece of the Celestron 8 telescope. And that's what you're seeing right in front of you here. The image on the left was taken probably around about 6:15 this morning. You can see that the moon has moved largely off the face of the sun. And then a few minutes later, the moon is all but passed from the solar disk. So this is live imagery, if you will. That was, well, it's not live now, but as they were imaging the sun, enjoying the eclipse, along with other folks out there in the early morning, you can see the progress of the eclipse very, very cleanly. He, of course, had a solar filter in place on the front of the telescope. You don't directly look at the sun ever, whenever you can see the solar disk in any fraction. So what we had here was the Celestron 8 tracking merrily. The sidereal drive was on, a lovely solar filter on the front end of the telescope, and then Jesse taking images with his cell phone. Very, very successful images out there enjoying the eclipse.
Indeed, and this is probably one of our more advanced setups for eclipse viewing. We did have, of course, lots of people going out to view it, and everybody took whatever they could find. There are a lot of ways you can view the eclipse. This is one possible way if you had a portable, large-sized or large-ish sized telescope. And it is a little bit funny. You say the telescope's older than your knowledge of Jesse, so I guess this is why he was saying earlier in chat that he was getting so many shout outs to people recognizing this retro scope. And
Yes, indeed.
we'll just go ahead and point out that they are wearing, both of them, eye protection as well. You can see that they've got on solar viewing glasses, which hopefully everyone has used. You don't want to look at these with your naked eye. So this is, two possible ways actually you could do it. You could go ahead and use a telescope with a solar filter on it. So there's a solar filter up at the top end. Or you could use glasses if you have the ones that actually cover your field of view. There are, of course, other options, and one of those was captured very, very interestingly by Observatory member Abteen, who was actually in a totally different location, Downsview Park. So I'm not sure I know where this is.
It's about 10 kilometers straight south of York University. So draw a line from York University to the CN Tower. 10 kilometers down that pathway, you will find the Downsview Park, near the Downsview Park subway station, GO train station. Very easy to get to these days.
Okay, well, good to know. So we're covering a wide area then, because we will be going back to York. We have one of our other observatory members was actually at York University and managed to get a view. So Abteen got this view, very, very spooky, almost Halloween sort of silhouette of the sun coming up with a phone and a solar filter. So this is no telescope at all. I suppose he just was holding the solar filter in front of the phone. And this one on the left here is what we were all referring to earlier today as the double eclipse, because it looks like there was something in the way. And I'm not sure if that's a tree or a really lucky shot with a bird.
I think he said it was a bird. Yeah.
It was a bird?
Yeah, which is I mean, as I understand it, yes, it's a bird.
That's amazing.
Which is it's a remarkable shot to take. That's absolutely incredible.
You could never take that if you were trying to.
Yeah.
Yeah. Well, this is amazing. So yeah, I guess now that you look at it closely, I can just see the outline of a little beak on the left here. So a little bit of a bird shape. And you can see that on the left image, the moon has sort of taken a bite out of the sun, and on the right image it's actually just a crescent. So he was able to capture the eclipse when it was closer to its maximum. So this might have even been very, very close to maximum just as the sun was rising. This is the moon covering almost all the sun, and it really matches up very well with what we have seen before, what we expected to see from a partial solar eclipse.
A nice crescent sun is what I have been referring to when talking to people, similar to the crescent moon that we're all familiar with. But of course, to see a crescent sun, very unusual. Very nice image, though, from Abteen.
Absolutely. And it was actually my first ever time to see any solar eclipse. So I was very excited, as all of us on the shared chat know. And it was great to see so many people from all over Toronto taking these wonderful pictures. So we also had observatory member Arfa, who was out there with a wonderful projection setup, which she made herself somehow. And it actually worked out really, really well, showing great crescent suns projected out onto a sheet. And this is really actually very crisp and clear projection. We're not quite sure where in Toronto she was this morning, but it was, of course, at that early 5:30, 6 a.m. slot. So great work by her to capture these, and really wonderful to see the different method here. So there's no filter in this place. So you can see this is just direct sunlight coming through.
And of course, basically a pinhole camera is what she has created here, a very tiny little aperture, having the sun beam through that aperture and taking natural advantage of the physics of diffraction and generating a wonderful, and as you said, really crisp image of the crescent sun.
Indeed, and speaking of pinhole cameras, I suppose we can continue that on and head out to Humber Bay Park, or Humber Bay Park East, I should say, which is where I was privileged to be this morning. And I actually found over there observatory members Kat and June and Kat's grandpa. And we were all setting up with a pinhole camera as well as a small Bushnell telescope. So actually, I'm going to just give a little shout out. Kat, you're here. Would you like to tell a little bit about the event?
Of course, of course. So this morning, myself and Dr. Hyde, we met at Humber Bay Park East, and we decided to go all the way to the point. We got a little bit lost, but we ended up finding our way around, and we saw some other photographers, so we knew that that was the appropriate place to put our telescope. So we had a few apertures with us. Not only did we have the Bushnell, but we also had the pinhole camera. We also had a makeshift solar, not a makeshift solar filter, but there was a solar filter that we mounted atop a makeshift mount on the Bushnell so that somebody could hold it in place whilst another person would adjust as needed, and looking through the eyepiece itself, which was done in both the far left and far right images, as you can see. So closer to the beginning of our adventure, we had sorry, could you go to the next slide? Perfect. So on the far left, we had we had most of the sun covered. So relative to the far right image, where it was nearer to the end, where there is where the moon is furthering away from the sun. In terms of what we used, we also did use a 22mm eyepiece to get a good magnification of the sun, and it was very difficult to get it aligned perfectly in the center. So we had some a bit of a struggle trying to get it in frame all the time, but I believe that was it.
Indeed. Well, we can actually show some of the wonderful video that you managed to capture, Kat. And this is, we can do a little contrast here. So this is, I believe, your view through the Bushnell. So this is just a little glimpse showing you how hard it is to study. But this is towards the middle to end of the eclipse. You can see, of course, the moon and that crescent sun shining through. And this is exactly what you would have seen if you were there with us this morning. And just to compare, if you look through the telescope, this is what you see. If you look through the pinhole camera, now this was another excellent video captured by Kat. You can see the image, but it's quite hard to get a good video of. So this is actually through that pinhole camera box that you all saw in the picture earlier. So the pinhole camera box will project an image on the back, and you can video it, but it is tiny. So you probably need a slightly better video setup than what we had. And I'll just go ahead and put up the comparison, because we also managed to capture some slightly less stable videos, which these were done by me, so I'm entirely to blame. Just showing the eclipse at the end here, where you can see the moon is moving off of the surface of the sun. And again, that's looking down through the Bushnell telescope. Even just a small telescope gets you such a good view on these. And you have to have the solar filter. So we absolutely could not do this without the solar filter in place. And this is our last little video attempt through the eyepiece, or second to last, I suppose, not necessarily in chronological order, but just to show you all what it looked like this morning at, 5:50 a.m., 6:15, something like that.
Have you got a photograph again of that pinhole camera, the shoebox that you took with you to Humber Bay?
Yes, I believe that one is...
Back it up a couple of slides, I think.
Yeah, I did have it on here. That is
The reason I mention it is that particular pinhole camera,
Here
there
we
you go, on the far left, is now a veteran of 2 eclipses. That was the pinhole camera that we created. We created several hundred of them for the big solar eclipse that was visible in Toronto, again as a partial eclipse, on August 20th of 2017. And so we literally went around to various shoe stores and vacuumed up all of their excess boxes, which they were happy to give us and get rid of. And we retained a couple of them, and that is one of them. So that particular box, Elaina, keep it because it's now the veteran of 2 eclipses. And of course, it will be around, I care to bet, for the April 8th, 2024 event.
Yes, and this was also mentioned last night in our TeleTube, but in case, again, folks missed it, the next one we're really looking forward to is the 2024 solar eclipse, which will be coming very, very close to direct through Toronto. And that is going to be an absolute amazing event. So really hoping for some clear weather there.
Circle your calendar right now.
And Quinton, did you have a little comment on Eclipse Maximum that you wanted to do?
Yeah, I just wanted to say that the Eclipse Maximum in Toronto happened at around 5:40 in the morning. And at that point in time, about 80% of the sun was covered by the moon. And for comparison, the sun rose at around 5:35 in the morning. So we could see that everybody had to get up very, very early indeed in order to get these fantastic images.
Yes, and you can tell who was able to do their alignment the fastest by how much of the sun was gone in the image, because as the sun was rising, we were getting our chance at that maximum eclipse. So now we've gone through Humber Bay Park. Let's go ahead and travel over to Vaughan. And Noah, we have you with us here, don't we?
Yes, we do. Hi, thank you.
Well, tell us how you did it.
For sure. So you could see here the images that I took of the eclipse this morning. And also you can tell, as Professor Hyde just mentioned, I wasn't able to catch the peak as Abteen did, but I did get the end of it, probably around 6:15 or 6:20. So I took these photos with my phone camera, actually, just through an eclipse viewer, actually the eclipse viewer that is pictured on the slide. And although I didn't go anywhere special like most of the other people did, I honestly just looked for the east horizon. It was still such a fantastic experience. It was just so surreal and honestly just amazing. I don't have words for it. It definitely didn't hurt that this was actually not only my first solar eclipse, but it was actually my very first eclipse in general. I honestly couldn't stop smiling the whole time and oohing and eyeing. It was just the most special experience. And I know that I'll never forget the moment that I held up the eclipse viewers and saw the sun with a giant portion blocked by the moon. I didn't know what to expect, and it was literally breathtaking. And now I just can't wait for the next eclipse. Well, I could probably go on and on, but I should probably hand it back to you, Professor Hyde. So thank you. Yeah.
It looks like you've also gone ahead and done an image direct through a filter with your phone, and it is a bit red as well. So maybe that's one way to get that beautiful red color, is to get those solar viewers. Looks like Discover the Universe eclipse viewers are pretty good for creating beautiful red images as well. Very nice.
Just on that particular point, a big shout out to discovertheuniverse.ca. They had done an awful lot of work for this eclipse. They had generated a wonderful website full of terrific resources that people could utilize for observing the eclipse safely. They had gone and translated it into a number of First Nation languages as well as French. Really a terrific site. And I know the eclipse was this morning, but discovertheuniverse.ca, if anybody wants to go over, and we haven't managed to answer all of your questions about eclipses and how to observe it and so on and so forth, that's a wonderful spot to go and check up on all of the unanswered questions from our perspective. So discovertheuniverse.ca, it's, as you can well imagine, a Canadian produced affair. It really is a great resource for any eclipse enthusiast.
Absolutely. And I believe they still have all of that good information up on their site. So again, if you missed it, you're not too late to get some good infographics. Okay. So discover the universe, very, very fun. And let's go ahead and see, we've got, I believe, 2 more locations that our observatory team members were able to get to. So without too much further ado, I think we'll go ahead and try Scarborough Bluffs. Now this is a really interesting one. Again, I'm actually not quite sure where Scarborough Bluffs is. Might be a little geography quiz for anyone who's in chat. And this was done by our observatory co-op student, Manny, who has actually used a really interesting technique for his sort of pinhole camera here. You can see that there are some projections of the crescent sun, but he's actually done a multiple image projection, which seems to spell out M3. So does M3 ring a bell for anyone?
Other than the Messier cluster?
It is, I believe it is for the Messier globular cluster M3, because I happen to know that Manny is currently reducing M3 data from our 1 meter telescope.
I thought it was MW, to be perfectly honest, and I was trying to remember what Manny's surname was.
Well, I think it's probably from the globular cluster.
Right.
And this is it's a nice way to bring our 1 meter to the solar eclipse here.
And the only way we're going to bring our 1 meter to a solar eclipse.
Yes, unless we get a very, very large filter.
Very large. The sun has got lots of photons, which of course is why something as small as Katz's Bushnell telescope was just fine. I mean, normally aperture in astronomy is really important to be able to capture more photons to give you better images. Not so for the sun.
Yeah, the solar observatories, you generally don't have a photon problem. It's
No.
well, you might have a photon problem, but it'll be the other kind.
Yes, too much of a good thing.
But yes, it is interesting. I'll just call out, if for those who didn't notice, how you would make this kind of M3 projection. If you wanted to spell out any sentence or make a shape, all you'd have to do is produce little pinholes that the sun could shine through in that shape, and then it would project the image of the sun that many times. So I'm guessing if we could get a little higher resolution, you would actually see that these are little crescent suns, each individual one, which is quite fun. You'll see some online where people have used colanders or kitchen utensils or other things. But
Pegboard.
Yeah, pegboard.
Yeah.
Pegboard. We actually have a pegboard that we didn't bring out. So there you go. But yeah, you can actually get as many images of the sun as you like. There are plenty of photons, as Paul said. So let's go ahead and move on from Scarborough Bluffs. And I believe we have actually over in the YouTube chat Manny right now. So if you have any other questions about these pictures, you can ask him if you're live in YouTube chat. He has confirmed that it is M3 for the globular cluster.
Well done, Manny. Well done.
All right, so let's go ahead and get all the way full circle. Speaking of bringing the telescope to the eclipse, well, from York University, it is possible to see east for the sunrise. I would not have known where to go, but fortunately, one of our observatory members, Palvisha, did know where to go, and she was able to catch these images of the crescent sun with a solar filter and phone camera. So this is quickly becoming one of our most popular methods here.
Arguably the simplest, of course. You know, when you're fighting the clock, you know, and you're fighting technology, simplicity does count. And so this is, you know, perhaps the word to the wise. And again, thinking ahead 3 years, when you are wanting to try and snap images during totality, keeping your setup as simple as practical is probably the most satisfying and safest way to get good images.
Yes, indeed. And I think that, what we have learned is that we should all make sure we order our own eclipse glasses before 2024.
Place the order now because they'll be in very hot demand.
Indeed. And let's go ahead and just go full circle here. So obviously this was all from our own observatory members who are out in the field. There were a lot of other people from Toronto and Ontario and Canada out taking pictures of the eclipse. So if you have a look online, you'll have a chance to see quite a few more. But I would like to give a little shout out to Rask and Jenna Hines, who have shared these with us specifically for our broadcast recap today. This is done with a very nice camera, I'm sure, looking in roughly the same direction as Kat and June and myself were this morning, but with a really good filter, she was able to capture the eclipse exactly as it was happening, sort of just behind the CN Tower of Toronto. So this is the iconic, if you're not in the Toronto area, this is the iconic CN Tower, so Toronto skyline. And you can see what's happening here is as the sun is coming up, you get the maximum partial eclipse here. And as the sun gets higher and higher in the sky, it gets more and more of a thicker crescent, which is where the rest of us were able to capture it from, with the possible exception of Abteen, who looks like he also was able to catch it really close to the edge.
Tip of the hat to Jenna. These are really stunning images. And the one on the lower left, of course, does show the 80% obscuration that Quinton mentioned at the beginning of the broadcast. The thin crescent sun there represents only about 20% of the solar disk. The other 80% is indeed obscured by the moon or that building. I don't know which building that is, but nonetheless.
Yeah, the moon and the building.
Yes, exactly. A little bit of terrestrial support there for the moon, but really nice images. And it shows you how relatively clear the day was. Just a little bit of gentle haze there, very, very thin cloud associated with sunrise.
Yeah, we really couldn't have asked for better weather. And if you would like to see more of these images, make sure to check out the Rask page, where I believe Jenna Hines has quite a few of these up at the moment. Very, very nice recap. So let's just go back up here. And Quinton, you had a little mention for the 2024 eclipse, I believe.
Yeah, I wanted to say, Noah, you aren't the only one who can't wait for the next eclipse. I am also really, really excited for the next opportunity to see one of these things. There's going to be another partial solar eclipse in the Toronto area in 2023. That'll be on October 14th. But we're also expecting there to be a total solar eclipse in 2024, which will pass right through Ontario. So that is absolutely a big opportunity. I'll certainly be writing down the Discover the Universe URL so that I could pre-order my solar filters for next time. Because if tonight has showed me anything, it's that those things are able to take some really, really nice results. So I'm looking forward to that for sure.
As are we all. And just as maybe a handy reminder here, as we're running through all of our different videos and everything, one of the big differences that will come with this 2024 eclipse is that it is a total solar eclipse that we're looking for. And this is where we get a very exact alignment between the Earth, the moon, and the sun, and the shadow will land right onto the Toronto area. And so this is where it's in the right distance. So it's not going to be an annular eclipse like the one we have now. There won't be a ring of fire, but you will get to see this beautiful glowing corona, again, with using safety glasses. Everyone, just don't damage your eyesight. It's very important. But it will be really, really spectacular. So if you haven't seen one before, you're in the majority. They are a bit rare in terms of, just they only cover a very small area and they tend to go over water. So having it come right through our own backyard here is just, as Noah said it best earlier, it is just too exciting for words.
It's a real treat. It really will be. One tiny little correction for you, Elaina. During the totality phase, when the moon is completely blocking the sun's photospheric surface and you're just seeing the corona, that is the only time during the solar eclipse where you can actually look towards where the sun is and do that without glasses. Because, of course, it's just the corona which is visible, and that is not dangerous to look at. But you have to be mindful of when the eclipse is going to return. So you have to be careful. But during the totality phase, when the moon is completely blocking the photospheric surface, it is safe to look into the direction of the sun and see the corona with your naked eye.
Exactly. So you will want to use your glasses right up until the point where you are sure it's in totality.
That's right. Exactly.
I wanted to add, when you are using the glasses to look at an eclipse, make sure that they are proper eclipse rated glasses. It is not sufficient to just be wearing sunglasses. I've had people ask me that question before, and I want to be absolutely clear. Normal sunglasses are not eclipse rated. They cannot guarantee that your eyes will be protected. So make sure that you're protecting your vision. It's extremely important.
Absolutely correct, Quinton. A very, very important clarification. Thick glasses of any description do not a solar eclipse glasses make. You've got to have the aluminized mylar, or if you've got welder's glass number 14, that also is rated for the type of energy rejection required to observe the sun. But the mylar sunglasses that we saw Jesse and Alex, for example, and I think also June and Kat wearing, those are safe. If you are buying those, before you use them, have a good look at them, make sure that there's no deep scratches or holes in them. It just takes a few seconds to inspect their surface and so on. Safety first is always, the motto when it comes to solar observing.
Absolutely. And just as a little follow up here, we do have a quick question from chat that we missed earlier, which I thought was maybe a fun way to round about towards the end of this eclipse recaps. But we had, of course, this lovely image from Abteen with the double eclipse happening with the bird and the moon blocking the sun. And we had a question in chat, which is great. Did the bird have eclipse glasses? And I think the bird would know not to look at the sun still.
Yeah, that's exactly right. No question.
Yeah, go ahead.
Well, I was just going to say, today, because nowhere in the eclipse path was totality, then all people should have been using some type of appropriate solar filtration. There was always enough of the sun visible, at least 10%, even in the annular regions of the eclipse, 10% of the sun's disk. People probably did not notice any change in the illumination that was surrounding them. 10% of the sun's disk, it mightn't sound very much, but the sun's a really bright object. So 10% or more of the sun's disk being present probably amounted to no significant change in your ambient lighting. That will be, of course, very different when you block all of the sunlight during the April 8th, 2024. When the sun is totally eclipsed, it really becomes twilight around you. And there you will experience significant changes in temperature, as in several degrees Celsius drop in temperature. The birds will suddenly feel that it is sunset. If you're lucky enough to be in a country setting, if there are cows nearby, you'll see them all sit down as if they're getting ready for a good night's sleep. They get very confused 3 or 4 minutes later when the sun comes up again. So being outside is really, really an important aspect to the total eclipse.
Indeed, and I suppose we would have a whole new possibility for interesting bird pictures once that happens. But yes, it's quite something to look forward to for sure. And I think I'll just go ahead and put back up here as a reminder to everyone our best video capture. So I think this is our most stable video capture of the eclipse today. with all of that area of the sun still showing, it's plenty to illuminate everything with. It still looks like full daylight. To the extent that it is, blocking the sun, that's plenty enough sun to illuminate your area and look like it's not really much different, actually, unless you have a telescope with a filter on it.
Now, partial eclipses, they have their own special charm. And as I think everybody felt today, watching the sun go through a differing appearance, seeing a significant chunk of the solar disk, the photospheric surface, being removed, it really generated its own mystique, its own interest level, its own excitement. And I'm glad that many of our students were able to get outside and experience this today. Hopefully the eclipse bug has bitten them, not too badly, so that the next time one is in the vicinity, or perhaps they'll plan their next vacation to end up in a part of the world where eclipses are taking place. Cruise lines, for example, cruise into darkness now regularly. They take whole shiploads of people into the paths of totality so that they can experience eclipses in all of their glory, all of their beauty.
Well, here's hoping that you finally get to go on those cruises, Paul.
Yeah. Absolutely. Yeah, give it another year.
And it is quite interesting as well when you see these objects. If you can just take a minute to picture for yourself, we see, of course, the sun changing due to the moon moving in front of it. And if you can, for just a minute, imagine how absolutely tiny the Earth is compared to the sun. It really gives you a sense of a little bit of the scale of the solar system, watching these things move across and watching the celestial dynamics in action here. So just definitely to emphasize it really sparks a lot of awe and I suppose inspiration for most of us who go out and see it. Now, Quinton, I think you have a little wrap up you wanted to discuss.
Yeah, just sort of related to what you were saying about how interesting it is to think about the scale of all this. One interesting fact is that the fact that Earth is a planet that can even get total solar eclipses is completely a coincidence, really, because it's just kind of happened to be the case that the sun is the right distance away and the right size, and the moon is the right distance away and the right size, that they appear to take up roughly the same proportion of the sky. And of course, there's nothing saying that had to be the case. You could have had, for example, a moon that was small, that was significantly smaller to the point that you could only ever get an annular eclipse, or we could have been in orbit around a star that was larger, and that would have also ruled out the possibility of total solar eclipses. So it's just kind of, I've always just found that really, really fascinating that we just happen to be in the sort of environment where total solar eclipses are possible in the first place.
Well, yeah, and if you wait long enough, the moon itself is slowly spiraling out from Earth and will eventually not be able to fully block the sun at all. So,
oh, what a downer! I mean, really, it's true, but it's still a downer.
No, nothing is constant in this, interesting solar system that we live in.
Well, alternately, of course, for the first scientists that managed to camp out on Pluto's surface, their total eclipses of the sun, courtesy of the satellite Charon, will last much longer than a few minutes.
Oh, yes, that's going to be absolutely spectacular. And I don't imagine that Pluto's atmosphere would interfere terribly with observations being so cold, but
Probably
I could be
not.
wrong.
That's right. Eclipses, be they solar or lunar, we haven't at all spoken about lunar eclipses, which are much easier for vast stretches of the planet to see. Literally when a lunar eclipse takes place, half of the planet is able to see what is actually happening, because of course the moon is sliding into the Earth's shadow, and the Earth so much larger than the moon. The shadow is very, very big. They too are really very spectacular. And of course, no safety implications there, because the moon is shining by reflected light. So you can look at full moon with safety. You can look at all aspects of the lunar eclipse with safety. They too are very, very impressive. A whole different type of eclipse experience, but nonetheless, in my opinion, still very, very impressive.
Yes, and it's just for more detail on that, we do have our episode from last night. But this eclipse is, of course, part of a pair. They usually do tend to go together. And the lunar eclipse that went along with this solar eclipse was on May 26th. And you might have heard about it in the news, blood moon. It was broadcast from some locations on Earth, but not from Toronto, because the side of Earth that was pointed at the moon for this eclipse was not including, any of us really over here. Just a tiny, tiny slice of the western side of North America, and Australia got an absolutely lovely view.
They did.
Most of the grid videos are actually from Australia, but yes, the whole side of the Earth that got to see the May 26th eclipse. They did have a slightly shorter lunar eclipse, and this solar eclipse that we had, it was a little bit longer than usual. So we had a little bit of extra time to take those pictures as the moon went across the sun. So we've had an interesting little eclipse season this year in 2021. It's been very fun.
You were saying, Elaina, that this was your first solar eclipse?
Yes, I had never managed to see one. I did get to see the transit of Venus, so I'm not, a poor astronomer or anything, but I did manage to catch that. But I have never managed to actually catch a solar eclipse before, so this was very, very exciting for me.
The first one that I recall was all the way back in October of 76, and that was a total eclipse which ran through Canberra. So I was in the right place at the right time as I was studying in Canberra, and we were all very, very excited. We went out into the countryside just so that we wouldn't have problems with buildings and the like, and it was dead clear. Although it did try to cloud over during the approach to totality, which got us all terribly agitated and jumping in cars and racing for cloudless areas. But unfortunately, it was just a transient amount of cloud, and we were able to see totality in that instance in all of its glory. But the first one is the one that I dare say we all will always remember. In my case, that was October of 76 in Australia.
Yeah, it is very, very memorable. So if you have missed this one, make sure to keep an extra eye out, as illustrated here by our observatory members, Kat and June, doing their best explorer viewing poses with the telescope. 2024 is the next really, really good chance. So I think this is probably a good place to wrap up this wonderful eclipse review viewing session. Hope you all have had a great time. I'm probably Paul. Do you have anything else you'd like to go ahead and say to everyone on our way out?
No, just make sure that you keep an eye on the skies when you hear that eclipses are coming, solar or lunar. Try your best to make some time available, because these events are very special. And as you said, Elaina, celestial motions in action.
Indeed. And if you would like this kind of thing and have had fun on the show, please make sure to come back again next week. We will be doing our regular Wednesday night TeleTube, which will broadcast every Wednesday night at 7:30 p.m. All right, everyone. So we're just going to go ahead and say thanks again for coming. We are very excited that we got to see this event, and we are very excited we could share it all with you. It was totally worth getting up at 4 o'clock this morning. And we will keep this episode up as a recording for you to watch again anytime. We will be broadcasting again next week, Wednesday, at our regular broadcast time, 7:30 p.m. for our next TeleTube. You have been listening to Allan Carswell Observatory's special event TeleTube broadcast. This astronomy and astrophysics program was written and presented by students, faculty, alumni, and friends of York University. Your hosts this evening have been myself, Professor Hyde. We have Professor Delaney here as well, and we have Kat, Noah, and Quinton all joining in live, as well as, of course, you saw many, many, many members of our observatory contributing pictures and videos into this event. All of our programs are free, but if you'd like to make a donation or buy one of our fabulous observatory astrophotography calendars, which are now at a 50% discount on the university bookstore, you can see our website at observatory.info.yorku.ca. You can always connect with us on Twitter at the handle @YorkObservatory, and check out our website for show notes, content updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, everyone. Clear skies and have a good rest of your day.